let's do some questions now. So n is 500 factorial. So we have multiple questions here. Let's look at all of them. 500 factorial. So what is the highest power of 2? For 2, you do 500 by 2. You get 250. 250 by 2, you get 125. 125 by 2, you get 62. 62 by 2, you get 31. 31 by 2, you get 15. 15 by 2, you get 7. 7 by 2, you get 3. 3 by 2, you get 1. Okay, so you will add all this. 250 plus 125 is 375. 375 plus 62 plus 31 plus 15 plus 7 plus 3 plus 1. Let's add all this. 250 plus 125 is 375. 375 plus 62. 370 plus 60 is 430. You have 437 plus 31. You have 468. 478. 483. 483 plus 7 is 490. 493. And 494. So answer is 494. Okay, then it is highest power of 3. Okay, obviously this value will be less than 494. So 500 divided by 3, that gives you how much? 166. 166 divided by 3, that will give you 55. 55 divided by 3 will give you 1. And 8. 18 divided by 3 will give you 6. 6 divided by 3 will give you 2. And 2 divided by 3 will give you 0. So we don't have to go there. Okay. So 166 plus 55. 160 plus 50 is 210. 221. 221 plus 18 is 239. 239 plus 6 is 245. And plus 2 is 247. So the answer is 247. Okay, next is 6. Now 6 you know is 2 into 3. 3 is a larger number, so you'll check the availability of 3, which we already have done. So your answer will be 6 to the power 247. Okay, next is 12. 12 again is 2 square into 3. Okay, so now 2 square is 4. 4 availability will be lower than 3. So actually we should check for 4 now. So if you check for availability of 2 square, now 2 was available 494 times. That means 2 square or 4 will be available 247 times. Right? So it is available 247 times. And incidentally, 3 is also available 247 times. So both of them are same. So in fact, because this is a power, this is not a prime number, this is a composite number raised to a power, hence both of them are coming as same. For prime numbers, always the higher number will have lower frequency, but 2 square is not a prime number, it's a composite number. So in that case, it makes sense to check for both. So obviously 12 to the power 247. Okay, why both of them are same? Because in the first case, in 6, there were so many extra 2's that we left out. Okay, 3 for 6 versus 12, we don't need any extra 3, we just need more 2's, and lot of 2's were available. Hence 12 also has the same answer. Okay, and then what is the highest power of 25? Now 25 is 5 square. For this we'll have to check for 5. So let's check for 5. 500 divided by 5 is 100. 100 divided by 5 is 20, and 20 divided by 5 is 4. So you have 124. Okay, but 124, remember, is the availability of 5. 5 to the power 124. I want 25. 25 means 5 square. So 5 square will become 62 times. So this answer is 25 to the power 62. Okay. And then the last question is, find the number of trailing zeros at the end of n factorial. Trailing zeros means in the end how many zeros would be there. Okay. Now how does a zero get formed? Zero gets formed when you multiply a 5 and a 2. So this again is a pair. So basically the question is same as saying it can be divided by what highest power of 10. Okay, because 10 is 5 into 2 and that will give you a 0 in the end. So you basically have to find the frequency of 5 and 2. 5 being the higher number, of course, will be present lower number of times. 2 will be present higher number of times. In fact, we know that 2 is present 494 times. 5 is present only 124 times. So tens you will be able to make 124 times. So there will be 124 zeros at the end, or it will have 10 to the power 124. It can be divided by 10 to the power 124. Both of them are same question. Okay. So we have done 6 questions just to do a recap of all that we have discussed about factorial. Okay. Now these are very basic plain vanilla questions. Let's bring some spice and let's look at slightly more complicated questions now. Okay. So now if 2100 factorial is 504 to the power p into q, where q is not a multiple of 7. Q is not a multiple of 7 is very important here, because 2100 factorial definitely will have 7, right? And all the 7s have gone in 504 to the power q. Okay. So let's do one thing first. Let's find out 2100 factorial has how many 7s. So divided by 7 is 300. 300 divided by 7 is how much? 40 will give you 280, so 42. 42 divided by 7 will give you 6. Okay, so you have 348. Okay, so 21 factorial will have 7 to the power 348. Okay, now we have 504. 504, if I factorize, that is how much? Is 2 into 252 into 2 into 126, 126, 2 into 63, 3 into 21, 3 into 7. That means 504 is 2 cube into 3 square into 7. So essentially what we are saying is that 2100 factorial is being written as 504, which is 2 cube into 3 square into 7 to the power p into q. Okay, and important part is where q is not a multiple of 7. So q can have 2, q can have 3. So you can't really do anything about 2 and 3, but it's not a multiple of 7. That means all the powers of 7 are here, and this, if you open, this will open as 7 to the power p. Okay, so 7 to the power p should match 7 to the power 348. Hence p is equal to 348. Your answer would be choice 4. As simple as that. So this hint was very important. Okay, so while the question might look complicated, if you understand what is being asked, what is being given, it's a very simple question. Okay, and the key part was q is not a multiple of 7, so you don't have to bother about powers of 2, powers of 3, because there's no information for that. Q may be a multiple of 2, q may be a multiple of 3. So I don't know, some powers of 2 will come under p and some powers of 2 will come under q. So I can't really determine anything, but 7 is the giveaway, and that should help you solve this. Okay, great. Let's move on. How many consecutive zeros will be there at the end of the product? Okay, so this is interesting. 2 factorial to the power 2 factorial into 4 factorial to the power 4 factorial into 6 factorial to the power 6 factorial, 8 factorial to the power 8 factorial, 10 factorial to the power 10 factorial. Okay, now this might look like a very complicated question, but if you try to understand this, there's not really much complication. Look at the first number, 2 factorial to the power 2 factorial. Now 2 factorial is what? 2 factorial is 2. 2 you raise to whatever power, there will be no zeros. So there are no zeros here. Similarly, 4 factorial raised to the power 4 factorial. 4 factorial is 1 into 2 into 3 into 4. There is no 5 there. So there is no 5 there. There cannot be a 0. 4 factorial also is 24, which you can see. So 24 you raise to any power, there will be no zeros. Okay, so no zeros here also. So first and second are not going to contribute any 0. Okay, because remember, to need a 0 you need 2 and 5, and first 5 comes in 5. So you should have at least 5 factorial. 5 factorial will have a 5. So 5 factorial is the first factorial that ends with a 0, which 5 factorial is equal to 120. Okay, so if you see, just for understanding, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120. Because 5 factorial is when you get 5 for the first time. A lot of 2's are there already, but there's no 5. So you get 5 for the first time. And now this 0 will continue. And then 6 factorial is 120 into 6, 720. 7 factorial is 720 into 4, which is 5040. It will go on like this till you get 10 factorial, and 10 factorial will have 2 zeros, because 10 factorial is equal to 10 into 9 into 8 into 7 into 6 into 5. So there is a 5 in 5 and there's a 5 in 10 also. So 10 factorial will have 2 zeros. So it will end with 2 zeros in the end. Okay. So then you will have 2 zeros till 11, 12, 13, 14 factorial. 15 factorial will have 3 zeros because it will have 3 5s. So that's how the concept builds on. So 6 factorial, okay, because it has a 5, 6 factorial will have a 0. So 6 factorial raised to the power 6 factorial. Now 6 factorial will have 1 0. So 1 0 raised to the power 6 factorial will give you 6 factorial zeros. Similarly, 8 factorial will also have 1 0, and raised to the power 8 factorial will give you 8 factorial zeros. And 10 factorial, we saw here just now, 10 factorial has 2 zeros. So 2 zeros raised to the power 10 factorial will give you 2 into 10 factorial zeros. So total number of zeros are going to be 6 factorial plus 8 factorial plus 2 into 10 factorial, which will be your answer choice 4. Right? As simple as that. That is going to be the answer for your question. Okay, so I hope we are clear here. And that's first and second number really does not matter. It is the third and the fourth and the fifth which will give you the answer. Okay, let's move on. So the next question is 2500 factorial is completely divisible by p to the power p. How many values of p are possible if p is prime? Okay, so 2500 factorial will be divisible by 2 to the power 2. P is prime, remember, so 2 to the power 2. It will be divisible by 3 to the power 3. It will be divisible by 5 to the power 5. It will be divisible by 7 to the power 7. The only question is, where do we stop? Okay, so now 2500, what is root of 2500? 50. So ideally, you should check at 50. And lower than 50, the prime number is 47. So is it divisible by 47 to the power 47? After 47, you have 49, 51, 53. Is it divisible by 53 to the power 53? These are two checkpoints that we should do. Ideally, this should not be there and this should be there. Okay, so to check 47, 2500 divided by 47 will give me 5. So you'll have 235 and then 53. 53 divided by 47 will give me 1. So 2500 has 47 to the power 54. So 47 to the power 47 is not a problem. This is fine. How much of 53 does it have? 2500 upon 53 is present 4. There is not 5. So 4. And then you'll have 212, so you'll have 38, 380. 380 will give you 7 times. So you don't have 53 to the power 53. So it will be divisible up to 47. Okay. How are you getting 47? Because 2500 factorial, when you write, basically it will be 1 into 2 into 3. It will go on and then you will get 47. And then you'll get multiples of 47. For example, 94. 94 is 2 into 47. Similarly, you'll get 3 into 47, which is 141. Similarly, you'll get 4 into 47. So that's way how you'll get multiples, and you'll have 47 multiples. Okay, so basically the answer is all prime numbers less than 50. And I hope you know that prime numbers less than 50, there are 15 such prime numbers. Okay, so the answer will be 15. Okay, so possible values of P are 15, which is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. Okay, so these are going to be your 15 prime numbers which satisfy this given condition. Okay, so this uses a bit of prime number concept also, and normally CAT questions will be like this, where they'll mix one or two concepts, and that's where you'll have to be careful. Okay, chaliye, let's move on. Okay, so let's see the next question. Next question is n is equal to 10 factorial plus 11 factorial plus 12 factorial up to 100 factorial. What is the highest power of 2 in n? Okay, now and see here the numbers are getting added. When the numbers are getting added, you'll have to be slightly more careful. Okay, what do we do here? Let's start by, we have 10 factorial plus 11 factorial can be written as 11 into 10 factorial plus 12 factorial can be written as 12 into 11 into 10 factorial, and so on, right? You have 99 factorial plus 100 factorial. Okay, so we are fine till here. Then let's take this 10 factorial out. Okay, take this 10 factorial out as common. So I'm left with 1 plus 11 plus 12 into 11, which is 132, plus what will you get next? So after this, this was your 10 factorial, this was 11 factorial, this was your 12 factorial. After this, you'll have 13 factorial. But remember, from 13 factorial, 10 factorial you've already taken out. So you'll have 13 into 12 into 11, 10 factor is already out, and then it will be further. So this is what you will get. Similarly, next one will be 14 into 13 into 12 into 11. This will be your 14 factorial, and so on. This is what we get. Okay, so this, if I write further, it is 10 factorial to 1 plus 11. Let's add these three at least. This will give you 144. Okay, plus 13 into 12 into 11. Let's take 12 out from that, from the remaining ones. So you'll get 13 into 11 plus 14 into 13 into 11 plus, you'll get like this. Okay, so here now if you notice and see this very carefully, this was a 10 factorial, this was 11 factorial, this was a 12 factorial. So here this 144 takes care of everything from 10 factorial to 12 factorial. Okay, and this is 13 factorial to 100 factorial. Okay, so how many numbers are there in this sequence? This sequence would have from 13 to 100, so basically 100 minus 13, and because the ends have to be included, plus 1. 100 minus 13 is 87 plus 1, 88. So they have 88 numbers inside. Right? Okay. Now let's do one more thing. We take 10 factorial. Then from this 144 also we take 12 out. So this will be 12. And then there is 12 common here also. That also has come out. So then you have 12 plus 13 into 11 plus 14. From 14 also 14 into 13 into 11 plus so on. So it goes on like this. Okay. Now focus on inside. This sum, this is going to be even or this is going to be odd? How many total terms are there? Now we have multiplied everything. Okay. So this, if you remember, we have taken this also. This was 88 terms. Okay. And now we have included one of this term also. This also has come one. So inside it has total of 89 terms. Okay. this has a total of 89 terms. Okay, now these terms, this sum is going to be even or it is going to be odd. If you see 89 terms, the first term is even. The third term is even. Okay, and after this, every term is going to be even. So this is the only odd term. 13 into 11 is the only odd term. All other terms, for example, what will be next one? Next one will be 15 factorial. So it will be 15 into 14 into 13. 12 will not be there because 12 we have taken out, into 11, and then 10 factor is already out. So that's how, so all of them are going to be even. All of them are going to be even except for this one, which is odd. Okay, so even, everything even, one odd. That sum will become what? It will be an odd sum. So what you have inside, this will be an odd total. So we can summarize the whole thing as 10 factorial into 12 into odd number. Right? That's how we can summarize the whole thing. So this will not give you any 2. 2's come from here. So 10 factorial has how many 2's? 10 upon 2 is 5. 5 upon 2 is 2. 2 upon 2 is 1. So 10 factorial has 8 2's. So you get 8 2's from here. And 12 is what? 12 is 2 square into 3. So you get 2 2's from here. Okay, 8 2's from here. So 8 and 2, you get 10 2's. So answer is 2 to the power 10. It has 2 to the power 10. Okay, so this is an interesting question, and that's how you will basically have to combine this to get your answer. Okay, because of course you can't solve till 100 factorial, so you'll have to simplify in such a way where after some time you get an odd number and you can ignore that. So that is what we did. So we combined 10 factorial, 11 factorial, 12 factorial, and then we left everything out, and then we saw that what you get inside is an odd number, and hence you get your answer. Okay, fine. Let's move on to the next one. By what minimum number should 200 factorial be multiplied so that it is divisible by 12 to the power 100? Okay, again, a very interesting question, one of my favorites. And rarely do I find students doing this right, though it has all the concepts related to this I've already taught you. You should not get this wrong. But there are few steps and you have to do all of them correct to get the answer. Okay, first is it has to be divisible by 12 to the power 100. 12 is a composite number. Okay, so 12 is equal to 2 square into 3. So you'll have to check the availability of 2 square and you'll have to check the availability of 3. Right? So 200 divided by 2 is 100, by 2 is 50, by 2 is 25, by 2 is 12, by 2 is 6, by 2 is 3, by 2 is 1. So 100, 150, 175, 187, 187 plus 10, 197. So 2 to the power 197 is present. Okay, and for 3 is 66, by 3 22, by 3 7, by 3 is 2. Okay, so 66 plus 22 88, 88 plus 9 97. 3 to the power 97 is present. Right? So this is what is there. What do I want to divide this with? Is 12 to the power 100. That means this to the power 100, which means 2 to the power 200 into 3 to the power 100. This is what I need. What I have is 2 to the power 197. That means I'll have to multiply it with 2 to the power 3 so that it becomes 2 to the power 200. and 3 to the power 3 so that it becomes 3 to the power 100. That is what I need. So I'll have to multiply with 2 to the power 3 into 3 to the power 3, which means 6 to the power 3, which means 216. Hence my answer is going to be 216 for this question. Okay, very nice question. And you have to do these small parts correctly to get the answer right. Okay, so that is how this will be solved. So you can see that how many different types of questions can be formed on the basic concept of factorials. Okay, let's do one more. You have 1 factorial into 2 factorial into 3 factorial up to 99 factorial into 100 factorial can be divided by what highest power of 10, or basically it means what is the number of zeros in the end. Same question. Okay, now here all the numbers are getting multiplied. This can be complicated. Okay, but let's see this. Very interesting question. 1 factorial will not have any 0. 2 factorial will not have any 0. 3 factorial will not have any 0. 4 factorial will not have any 0. This we discussed in a previous question, right? So they will not give you any 0. 5 factorial will have a 5. Basically you're looking for 5, right? Because 10 is 5 into 2. You don't have to bother about 2. You only have to bother about 5. 5 factorial will have 1 5. 6 factorial will have 1 5. 7 factorial will have 1 5. 8 factorial will have 1 5. 9 factorial will have 1 5. So that means when you multiply them, 1, 2, 3, 4 does not matter. They will not give you any 0. But when you multiply 5, 6, 7, 8, 9 will give you 5 into 5 into 5 into 5 into 5. That means they'll give you 5 to the power 5. Each one of them will give you 1 5 and they all are getting multiplied. So you'll get 5 to the power 5. Okay, 10 factorial will give you 2 5s. So what we'll need to do is we'll need to club it. 5 factorial to 9 factorial. I'll get 1 5 each. 1 each. That means total I'll get 1 into 5, 5 5s. 10 factorial to 14 factorial. I'll get 2 5s each. Total that means I'll get 2 into 5, 10 5s. 15 factorial to 20 factorial, to 19 factorial, sorry. I'll get 3 5s. So total I'll get 3 each. So I'll get 15. 20 factorial to 24 factorial. I'll get 4 5s. So 4 into 5. Okay. 25 factorial. Again, people make a mistake here. 25 factorial will have how many 5s? Till 9 factorial you had 1 5, till 14 you had 2 5s, till 19 you had 3 5s, till 24 you had 4 5s, 25 you are likely to think that you'll have 5 5s, but no. 25 is 5 square. So 25 will give you an extra 5. Just to check, 25 upon 5 is 5 and 5 upon 5 is 1. So 25 has 6 5s. Whereas 24 upon 5 is 4. It has only 4 5s. So 24 factorial has 4 5s, which is what we have taken. But 25 factorial has 6 5s. So 4 jumps to 6 because 25 is 5 square. Okay. And that is where you'll have to be careful. So 25 factorial to 29 factorial will be 6 5s into 5 of them. 25, 26, 27, 28, 29. Then 30 factorial to 34 factorial, there'll be 7 5s into 5 of them. 35 factorial to 39 factorial, there'll be 8 5s into 5 of them. 40 factorial to 44 factorial, there'll be 9 5s into 5 of them. And 45 factorial to 49 factorial, there'll be 10 5s into 5 of them. Okay. Then comes, so this is slightly longer solution, but all your concepts will get clear here. Then we come to 50 factorial. 50 factorial, same thing will happen which happened in 25 factorial. It will jump. So after 10, you'll not get 11 5s, you'll get straight 12 5s. And we can check that 50 by 5 is 10 and 10 by 2 is 1. 10 by 5 is 2. So you'll get 12. Okay. So 50 factorial to 54 factorial, you will have 12 into 5. 55 factorial to 59 factorial, you will have 13 into 5. 60 factorial to 64 factorial, you will have 14 into 5. 65 factorial to 69 factorial, you will have 15 into 5. And 70 factorial to 74 factorial, you will have 16 into 5. 75, same problem will happen. 75 to 79. Now if you check for 75, 75 divided by 5 is 15 and 15 divided by 5 is 3. You get 15 plus 3, 18. So you don't get 17. So 18 into 5. Then 80 factorial to 84 factorial, you will get 19 into 5. 85 factorial to 89 factorial, you will get 20 into 5. 90 factorial to 94 factorial, you will get 21 into 5. 95 factorial to 99 factorial, you will get 22 into 5. And then 100 factorial. 100 factorial will be how much? It will again jump. 100 upon 5 is 20. 20 upon 5 is 4. You will get 24. But not into 5 because it's a single number. So you will get so many 5s. Okay, how to add all this? Okay, simple. If you all are getting multiplied with 5 till here. Okay, so 5 will multiply with later. But if you see, you have series of natural numbers from 1 to 22 with some numbers missing in between. So you have 5 missing. You have 11 missing. You have 12, 13, 14, 12, 13, 14, 15, 16. You have 17 missing. Okay, so basically from 1, 5, 6, 7, 8, 9, 10, 11 is missing, 12, 13, 14, 15, 16, 17 is missing, 18, 19, 20, 21, 22. So let's add natural numbers up to 22. So 22 into 23 by 2. So this is 11. 230 plus 23, you get 253. From this 253, let's subtract 5, 11 and 17. Then we'll have the total. So 11 plus 5 is 16, 16 plus 17 is 33. So 253 minus 33, you'll get 220. Okay, and remember everything was getting multiplied with 5, so now we multiply with 5, you get 1100. And then you add for 100. This has to be added later because this is not getting multiplied with 5. So plus 24, you'll get 1124. So answer is second choice. So this can be divided by 10 to the power 1124, or this has 1124 zeros in the end, or this can be divided by 5 to the power 1124. Same answer because 10 and 5 both are multiples of 5 and 2 is not in short supply. Okay, so this is a slightly longer answer, but again a very good question to clear all concepts related to factorial. Okay, so this brings us to the end of this class. Factorial, as I told you, is a small and simple concept, but there's so many interesting questions that can be framed on this concept. Okay, so thank you so much for being attentive and watching this class. I hope you have taken down notes and you have understood the questions. In case any question you have not understood, please go through that question once again. And then we will meet in the next class where we are going to discuss the very important concept of remainders. Okay, remainder again is one of the core concepts of number system, and we are going to look at remainders in so many different ways. Okay, so thank you, take care, bye bye.